Okay, so in this task we're going to be doing add node at the end. So we're going to be adding a node to the end of a singly linked list. If you look at the list I have over here, I don't know why this thing is hanging. Okay, when it loads, I'll kind of explain. But before that, let us get our prototype, right? We'll paste it, copy. So there are several ways to do all these tasks. Like there's no single way to do them. Okay, so just find what is clear to you. Make sure that what you're doing you quite understand, and I think that will go a long way. So I'll put this one in my prototype, right? Okay, good. All right, so let's see. It's okay, good. So let's say we don't have this, or let's say we have all this, and then we want to add extra node, right, to this end. Remember that the end would always have a null at the end, right? So if we are to add an extra, it means that we'll pass in that node here, right? And that node will have a data like this, because we'll have an integer, and then it will have a null at the end, and this null will pass the address of this guy to it. Okay, so that's basically it. Let me see if I can use this guy to explain as well. So what we're doing is we'll pass in a what's it called, we'll use this guy, right? We want to add extra one here, right? Extra node, right? Node E. So when we are adding it, we are passing the address of this thing to the next one. So we are passing we are collecting the address of this guy to this place, right? And then replacing the last one with null. Okay, so that's what we want to do. So what we're going to do is we are going to iterate through all these nodes, and when we get to this null, right, we'll come out of that loop, and then would pass in that place, the address of that place to this one, right? And we would initiate or initialize the address of that last one that we are creating to null. Okay, so that's what we're just going to do. So I think we've copied the list.h. So what we're going to do next is so we should return null if it fails. Okay, so let us create the 3main.c. I'll copy this guy. So vi 3main.c, paste it. Good. So that's that. And what else? Would let's create our file, right? So add node at the end dot c. So copy this, paste it, vi this, right? And then we'll get our prototype back. Maybe the prototype should come last. So we'll include our main, sorry, so I'm used to main, our lists.h. But last task I was sleeping, I was dozing off. I have to wake up like this to continue. All right, so so we'll add underscore node, add node int underscore end, right? So add a node to the end of a list. All right, and then we have at end, right, which is the point pointing to the end of the list, and then we have at n, right, which is the is an integer value or data to be added, to the new list, right? So we have our return, so it should just return the address of the element, right? It's going to return the head, right? It's going to return the head, and then we'll end it like that, and then I'll come here. So what I'll do is, we can't use this head to iterate through, okay? Because by the time we use head to iterate through, we will not be able to access all these things again, because by the time the head leaves this guy, all these guys will be wandering around and we will not be able to go back to them. So what we're going to do is, we are going to have a temporary head, right? We're going to have a temporary struct, right, node, and then we'll pass in the value of this guy to it, and then we can use that temporary to iterate through while this one stays. And then we're going to create our node for the new node we want to add at the end as well. Okay, so basically that's it. And then we'll say list int underscore t, right? And then this one should be the new one. List int underscore t, and then this one should be the temporary that we'll use to iterate through, right? Good. So what we do is, I think we're going to void them. I will explain why we have this line later. Okay, so I'm just trying to typecast it. All right, so the first thing we're going to do is, we're going to, for this new, we're going to allocate memory for it, and then if the memory allocation fails, we will return null, right? If it doesn't, then we would initialize its head, its data to be this n, and then its address, right, its next, to be null, because it's going to be the end, and the end will always end with null. Okay, so that's what we'll do. So we'll say new equals to malloc brackets, and then we'll say size of, right, size of, and then size of what, list int underscore t, right? And that should end that. So we'll say if our new is equal to null, then it should what, return null, right? Good. So if not, right, our new n will initialize with n, right? And then our new next we initialize it with what, null. We initialize it with null because it's going to be the end guy, right? So that's what we're going to do. And then we say temp. You remember I said we would give temporary the address of head, right? What is the content of head, which is the address of the first node, right? So we'll say void equals to star head, right? So this is what we're gonna do, and then we'll end this part like this. So we're almost done. So the next thing we're gonna do, we'll say if our head is pointing to null, right? If our head is equal to null, okay, so it means that there is no data. Probably it's either pointing to the last guy, right? Or it means there's no data, obviously. All right, so if it is pointing to null, then let me like this, right? Okay, good. Then we would say our, it means that it's not pointing to anything. Then we'll just connect the head to new, right? So our head will be new. So what I'm saying there is just that if this guy is pointing, let me use this other picture. Okay, good. So if this head is pointing to nothing, then just carry the new node we want to write, put it here, and then connect this guy to it. Since that one is now null, right, and then we initialize the data, then it is working perfectly, right? So that's what we're doing there. So we'll come down and say else, and then we'll have our loop, right? We'll say while our temporary next. So we have a while loop or a for loop is not equal to null. Now we are using that temporary to go to the next like that. So we are using temporary that we've created here. So temporary will be beside here. We've passed in this value here, which is the address of this guy. So temporary would check and then see the next. Okay, is this one null? Is this one null? So once it gets to null, it will end that loop. So that's what we're going to do. So we're going to want to make it move to the next here. So we'll just say our temporary, right, is equal to temp next. Okay, so this one will make it keep going. So by the time it gets to this guy at the end, right, to this guy, we want to come out of that loop. Okay, we don't want to do anything while inside that loop. So when it gets to null, it will come to the next line, and then once it comes to the next line, what we're going to do is say this next, this guy, right, that is null, right, we want to pass in the address of the new one there, right? So that's what we want to do. So we want to pass in the address of the new one. So we say then temp next equals to name. Okay, and that's that. And since our new one has a null at the end already, there's nothing else. I think we're done. So we'll just return. Let me put a space for my return. So we return head, right? And that should be all. So let us bet the file. Okay, I think we're good. What else? Let us compile. This one is called D. Okay, good. 0 to 1024. Let's see. 0 to 1024. Okay, that means we are in the right track. So let us git add, git commit. I will say add node to the end of a list, right? And we'll git push it. Okay, so let us check our code to see. This is checker time, so we might be having checker issue because it's almost deadline. So I'm just going to probably end it if it doesn't work in next 1 minute, and if I get any error, I'm going to amend this video, right? So I would see you guys in the next one.